And now I am going to invite Nicholas Lyle from Concordia College to talk about the introduction of Arduino microcontrollers in the instrumentation lab at the Concordia College. Nick, please share your screen.
Can you all see it?
Yes.
Cool. Okay, so hi, I'm Nick Lyle, and I'm going to be presenting my research on, this is from last summer, on Arduino microcontrollers in the instrumentation lab at Concordia College. This was all done with the help of Dr. Thelma Burkwell. The main motivation was to simply introduce microcontrollers to the Introduction to Instrumentation course here at Concordia College. It's offered during the first semester of the sophomore year within the physics major, and it's offered at the same time during the second semester of the calc-based physics course. And it's also a block course where it's taken after we take our Introduction to Computational Physics course, which is just the programming for physics problems and all that fun stuff. Some more background on the problem here. The faculty member who previously taught the course retired. So we decided to update the course and sort of modernize the course with microcontrollers. And at Concordia, they're also used a lot in extracurricular activities. So it only made sense to use these in the course. Before we can go on, we got to know what a microcontroller is. And it's essentially just the most basic form of a computer. It's the heart of it is the processing unit, specifically in the one that we use, the Arduino Uno. This is the heart right here. It's specifically the ATmega 328P. Allows for a basic analog to digital conversion. And it also opens up some 5 volts power through a voltage regulator, and it's a lot of fun. The purpose of a microcontroller is just to perform specific sets of functions with as little latency as possible. So basically you tell the computer what you want it to do, and you want it to do it as like right when you tell it to do it. There's the applications of microcontrollers. They're all over the place. You probably use them minimum 10 times per day. They're in your cars, they're in your remote controllers, they're in your home theater receivers, they're in your power tools, they're in multiple medical devices, and they're in office machines. And that just scrapes the top of the list. It can go on for a long time. And this is all thanks to embedded systems engineering. And they basically take hardware, some software that they make, and they make it into one product. A lot of fun. Why do we specifically use the Arduino Uno? The Arduino is cheap, and the specific kit that we picked, the Arduino Starter Kit, it costs around $90, which is not that expensive considering what you can do within Arduino. And another main reason that we picked it, the Arduino is very user-friendly with it using the C language. When you compare it to the main competitor of the Arduino, the Raspberry Pi, which uses Python, C is not that complex when you compare it to Python. So with the time constraint given with the course only being a half of a semester, it made sense to go with the Arduino. And it also acts as an embedded system where it constantly loops. While with the Raspberry Pi, you have to modify the code where you have to tell it to loop. And on top of that, the input and output tasks are simplified. You'll see that later in a specific project, how it's simple. And also the Arduino is open source, and the community that uses it is huge. So you can ask questions anywhere, essentially. And what will the students learn by using the microcontrollers? They're going to learn a lot. And the biggest part, they're learning fundamental electronics with their hands, where it's different than reading a book, because when you read a book, you're going to read a lot of schematics, and part of understanding how a schematic works is actually making a circuit. And they're going to be doing this on a breadboard. which when you use a breadboard for the first time, it can be pretty confusing seeing all just how like when you plug a thing and you can't do it like this, you probably have to do it like that. And where through that you'll learn trial and error. And on top of that, you're going to learn, they're going to learn simple programs, and they're going to make those programs communicate within a circuit. And all this as a whole is the basics of embedded systems. So they're going to be learning how to make embedded systems. Here's the Arduino Starter Kit that we picked. We picked this kit because it introduces a lot of fun basic coding projects. They get to learn some pretty simple electronics. Contains several components, and it comes with a book with instructions for 15 different projects. We specifically picked 9 projects from the 15 in there just because of the time constraint for the course. So these ones we felt they would learn the most instead of just going through 6 short projects or 6 longer projects. How will it be used in the instrumentation lab? Through multiple simple projects with the Arduino as the heart of each project, where each project, there's one purpose for each project, and you learn one new thing through each project, while at the same time they build off of each other, so they don't really, it keeps on climbing, you keep on climbing up a ladder type thing. And this is just the first project that they learn. It's just simply turning an LED off and on using a delay and a loop. And this is the digital output here. It's just, you just sell it to digital write, and that's how you output to the LEDs or whatever that you want it to output to. And these are just some of my favorite projects. This one here is a piezo, or it's this basic speaker, where they make a little keyboard type thing where you send a frequency to the speaker, and that uses a bunch of push buttons. There's some projects that use a potentiometers or variable resistors, where you vary the resistance in the circuit by turning the knob. This one up here is pretty fun. It's sort of a basic thermometer where you put your finger around the temperature sensor, and by the temperature that the sensor's reading, these lights will start to turn on. Yeah. I'd like to thank the NASA Minnesota Space Grant Consortium for funding the project, and I'd like to thank Concordia College Undergraduate Research Scholarship and Creative Activity for the opportunity for this research. Are there any questions?
Okay, Nick, you was fast, and again, the usual question: why do you think it's important to learn about microcontrollers? How this you have an impact for NASA? Why this project is interesting?
I think it's an interesting way to learn electronics, and you also get to learn a little bit of programming at the same time.
In the course you're using it in, what were you replacing kind of similar labs with ones were augmented by the Arduino, or doing entirely different things?
Oh, it's different things. The previous lab, but it was a bunch of RLC circuits in the previous lab. I kind of wish I could have figured out a way to incorporate those in the Arduino kits, but yeah.
So, Arduinos also are something that hobbyists really get into and do a lot with. Have you done anything around your house or thought of any projects or things like that? Oftentimes that's one way that students sort of really take the Arduino. Or have you seen that in the course?
In the course, the students, they actually get to make their own project at the end. And one project that I've been trying to work on is a frequency generator using a potentiometer, and you can plug in a scope to it and you can see the waveforms, which I think would be pretty cool to see those things work, or how they work.
Any other question? Okay, so Nick, you can stop sharing your screen. And the next maybe we can start a little bit earlier. The next presenters are all three of you around. I see. Okay, so I'm going to stop. As before, I'm going to stop this recording.